I apologize for the third video. So now we have to do another number line, 0, 2, and find y double prime of -1, y double prime of 1, and y double prime of 3. This is going to tell us where our concavity is. So -1, 12 times negative is a negative. 1 minus 2 is a negative, so we're at a positive. 1, positive, negative, negative, and 3, positive, positive, positive. So we're concave up from negative infinity to -1, always open brackets for concavity, and 2 to infinity. Concave down, we're 0 to 2, open brackets. So decreasing, increasing, close brackets. When it's a number, concavity, always open brackets. And so the final part now is to graph this. Let's get better axes. And so when we graph this, the one thing that we do need to look at is, it says relative min right here. Well, what is our actual point? And so if we were to plug it in, we'd get 3 to the 4th minus 4 times 3 cubed. And we're actually going to get 27. So our relative min's at 3, negative 27. And so when we move down here, we know that at 1, 2, 3, we're going to be somewhere, I'm going to call this negative 27 right there. Right there. So that's one of the points we know. We also know that we go through the origin, 0, 0. And when we also look at it, the original problem was x to the 4th minus 4x cubed. If we set that equal to 0 to find our x-intercepts, x cubed, x minus 4, we know we're also at 4. So we know we have our x-intercepts at 0 and 4, and we know that we have a minimum at 3, negative 27. And so using everything we know that we are increasing from, what do we say, we're decreasing from 0, negative infinity, to 3. So we're decreasing. We know that we're increasing beyond. And we know our concavity is changing right here. Concavity, we are up. From 0 to 2 down. And up after that. And so that's approximately what we know, and we just know that we have a negative 3, negative 27. So we're decreasing in concave up again. If you want to draw your smiley and frown face. So decreasing concave up. So I'm going to look here, and we're decreasing. So I know that I'm going to look something like, like this. So we're still concave up. Now we go to concave down, but still decreasing. So point of inflection. And we're going to change concavity at 2. So decreasing to right about there. And then concavity changes to back up. And I know that our decreasing, this is our minimum, so I know I have to go back to increasing. I have to fit through that point, which is a very poorly written point. Maybe I'll change that to make it a little easier for me. And again, you're just sketching. This is just a sketch. You can say that's 4. So, change concavity, hit there, come back up. You can make believe that's 4 right there. That's 4. Okay? And so, again though, the key point here, and I'm trying to do this, we can do this better in class if we want to, but the key point, concave up, holding water, concave down, dumping water out, until we get to this point right there, where I need to change, a point of inflection occurred right there, the point of inflection did, back to holding water, and then back straight up, and I'm increasing throughout. The last part of this is something that you guys may struggle with, but I hope not, is looking at how to graph the derivative of an original function. So what I want you to do is kind of take specific points. What is the derivative at that point? Well, we don't know it specifically, but we do know that it is the slope is a high negative value. It's decreasing greatly. Here, decreasing still, but medium. So medium negative. This one's 0. This is a low positive. It's slowly increasing. And both of these, I would say, are high positive. And so therefore, when we go to graph it, a high negative, okay, is way down here. Stayed a little high, a little less. Medium, low, 0, low positive, medium positive, high positive, high positive. So if we connect this, we can kind of see that it looks a little bit like a cubic. And why does that make sense? Well, this looks like an x to the 4th graph. What's the derivative of it? 3, 4x cubed. It looks like a cubic. Now, again, what you can do to graph these is give that a value, -10, -7, -1 there, 0, 1, 8, 15, something like that. And then actually graph them as points down here. The graph probably should have looked a little bit more like that. The absolute value one's a fun one to graph because what do you notice about all the slopes of all those black points? They're the same. The slope of that's -1. So when you go down here and graph it, this is -1. All of those are -1. What about here? +1. And so the slope there is +1. So we can say that's 1 and this +1. So we know we create a line. But the question is, what is it at 0? Well, we talked about this at the very beginning of the video, which I know seems like a while ago, does not exist. The actual derivative right here does not exist. And so therefore, what do we need? We need a hole. So the slope's -1 all the way until 0. It does not exist at 0, so we have a hole. It's not defined, and then we have it 1 after that. What about this one? Well, what do you think the slopes are from this line and that line? If you look at them closely enough, they're actually parallel lines. The slopes are the same. Let's see, what do you think the slope is about? I'm going to go guess. That's -4 right here, 2.5, so 4 over 5 halves. Flip and multiply, we're going to get 8 over 5. So the slopes are right around 1.6 for both of them. So we'll say 8/5 there approximately. So the line that we're going to draw is a straight line with a hole at 0 and then another straight line back. Why is there a hole? There's jump discontinuity. The derivative does not exist at 0, hence the hole. So, just to recap a little bit, we're not going to do this one. When you are finding max or mins, 1, take derivative. 2, set derivative equal to 0. What does this do? This gives us our critical values. Our critical values we then use our critical values are either a max or min or point of inflection. Okay? That's what the critical values are. For number line, and then with that number line you're going to find decreasing and increasing intervals. Okay? With that you can also find your local min and max. 5 if needed, second derivative, set equal to 0, and this will give you your concavity. Okay? And then you're going to graph it from there. We will definitely practice a lot of this, so if you're struggling with it, do not worry. We have 3 days to practice this. So, good luck, and I'll see you in class.